So on this first set of exercises, you want to match the columns, the first column with the description in the second column. So just take a few minutes to work on that. And while you're working it, or think about it, this is straight out of your textbook in the back, so you can pull that up. But some of them are easy, and the best thing to do when you have matching is what? Process of elimination. Go through, do everything that's intuitive to you and that you get, and it's easy. Mark those out. Then there's going to be a few that's a little bit tricky to us. So let me come over here and kind of talk through. Let's just talk about the first one. 1, 3, 5, 7, 9. That's clearly odds. Let's go over to see anything with odd right off. Set of all odd integers. Well, that's not all of them. So D, I want to be careful not to let just the word odd throw me off. So F has the word odd in it as well. The set of odd positive integers less than 10. Well, that makes more sense, so I can tag that. So 1 is F. Number 2 says X such that X is an even integer greater than 4 and less than 6. Okay, just because whenever I'm reading through that, I don't know how you think, but that one's not as easy as like even and odd stuff. So I'm just going to come back to that one because I'm going to think about it for a little bit. Not that I couldn't tackle it as I go, but process of elimination usually is going to make this easier for us. So let's go to the next one. -4, -3, -2, -1. That's negative integers. Let's just come back to it. The next one that looks easy to me right off is 2, 4, 8, 16, 32. So it's not the set of all even integers. I know they're all even numbers. But what about those numbers? They should be starting to look familiar to us. They're powers of 2. 2 to the first power, 2 to the second power, 2 to the third, 2 to the fourth. So see if there's anything over there. B, the set of 5 least positive integer powers of 2. So basically starting with the smallest one, moving to the right. So that one's not too bad. I feel like 5 you could pick out pretty quickly. So let's do 5 as B. I'm going to jump to 7 next just because it seems like the next easiest to identify. 2, 4, 6, 8, 10. Obviously something to do with even numbers. So I look at option choice A, set of all even integers. No, that's not all of them, but it is even numbers, so I keep reading through my list and see. Bless you. The set of even positive integers less than 10. Okay. But that one includes 10, so I can't use that one. But this one is right underneath it, so let me go ahead and mark that as C. 2, 4, 6, 8, even integers less than 10. So then I jump back up. The only thing, H is the set of 5 least positive integers with multiples of 2. Multiples of 2 means you're going to have an even number. So that's a multiple of 2, that's a multiple of 2. So basically you multiply by 2. I have a 2 that's factored in there, okay, because this one's 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, so therefore it's a multiple of 2. All right, so we've taken out those, and we're going to come back. We still have 2, 3, 4, and 6 left. So let's go back up to 3. 3, it looks like everything in there is going to be what? Negative, because this says keep going to the left for as long as you want to count. Well, on the number line, what's to the left? All negative numbers, and it's including every one in that direction. So 3 is just going to be the set of all negative integers. So that wasn't too bad. Jumping down to 4, we have going in this direction, 1, 3, 5. Coming this way, -1, -3, -5. So odd numbers for sure, but odd numbers in both directions, in the positive and the negative. So that is the set of all. And why do we get to say all? Because of the dot 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 this way that covers all the odd positives, and then dot 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 this way that covers all the negative odds. So therefore, all of the odd. And I think 6 was the last. So similarly, 0, 2, 4, 6, 8, all positive even numbers. -2, -4, dot, dot, dot means keep going that way. So we'll have set of all even integers. Okay, so that's just some practice. Really, your biggest friend there is to take and do process of elimination. Because once you take out all the things you do know, then you can go back and kind of backtrack, and it makes things a little easier. So the next is all the counting numbers less than or equal to 6. So your first example that we're going to do together is going to be list all the counting numbers. So make you a set, okay, that includes all counting numbers less than or equal to 6. So that means you will include the 6. So we'll have what? 1, 2, 3, 4, 5, and 6. All right, our next one is we're going to fill in the middle of that thing. So we want to complete the set. So they didn't give us the entire set. List all the elements in the set. So this one, it didn't show us everything. So it starts with -15, -13, -11. What's next? -9, -7, -5, -3, -1. Oh, stop at -1. Okay, good. X such that x is an even whole number less than or equal to 1. Oh, 11, yes. Thank you. Even whole number. What's the whole number tell you? Include 0. Good. So it's 0, and then we're doing even numbers. 2, 4, 6, 8, 10. Stop at 10. Because the next one's 12, and it's out of our criteria. Okay. The setting all counting county numbers greater than 20. So here's the way we would do that. Because it's all greater than 20, we start at 20, and we do 21, 22, and then what can we do? Dot, dot, dot. Because we want all of them, so the all is a keyword, so we're going to have that dot, dot, dot. Just we got to determine which direction it's going since we're going greater. All county numbers greater than 20.
If you include 20, what should it say greater than?
Oh, greater than 20. You should not include 20. So start at 21. Thank you. Start at 21. So let's put 3. 3 is usually a good, it's sufficient. 21, 22, 23. Thank you for catching that. So this next part, we want to know is, let's see, identify as finite or infinite. So let me put this in there. So identify as finite or infinite for the next one. What do you think? 1/2, 2/3, 3/4. The next one will be 4/5, 5/6. What about the dot, dot, dot? Keep going, so infinite. Good. All right. X such that X is a natural number, natural number less than 50. What do you think about that? Could you give me the cardinal number of it? Cardinality? Yeah, because we know it's something less than 50, so we can count those. That's the counting numbers. So that one's definitely finite. I didn't ask you to give it to me, but you could if I wanted you to. All right. Set A has how many elements? 1, 2, 3, 4, 5, 6, 7. Looks like 8 elements. Can you finite or infinite? Can you count it? Yep. What is the cardinality of that? So go ahead and name the cardinality. So on top of that, let's do find cardinality. Of A. So it's finite, but also give me the cardinality of it. So cardinality of A is equal to, we said, I think I counted 8 elements there. All right. We have the element A for the next example is 2, 4, 6, 8, 10, dot, 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 all the way up to 1,000. Now that's finite because we know it starts at 2, stops at 1,000. So I should be able to give cardinality of this. Let's talk about it. If it's evens, it's only given half of them, right? Or every other one. Well, how many do we stop with? 1,000. So if there's 1,000, but we're only doing every other one, how many do we have in there? 500. Good. Okay. So the next questions that we're going to look at, we're going to say identify as well-defined or not well-defined. So this part is identify as well-defined or not well-defined. All right, let's talk about them. X, such that X is a real number. Is that well defined? Yeah, we defined this earlier. We talked about what a real number is. There's tables, there's charts that help with description of that. If I told you a real number, you'd have a pretty good idea of the classification and how it's defined. So we would say well defined. What about the next one? X such that X is a good athlete. Well, I'm a coach, so my idea of what a good athlete might be different than someone who doesn't play sports, right? So whenever it's X is a good athlete, well, that's not well defined because it depends on who you're talking to, what sport are you talking about, like what is this a sport or not? So this is not well defined. The next one is the element X such that X is the element of a difficult course. So X is a difficult course. Well defined or not well defined? Not, because for some people it might be easy and other people it might be hard. So that one's not well defined either. What about X such that X is a counting number less than 2? Yep. We know exactly what it's talking about, so this is well defined. All right, on these next ones, we're going to say fill in the blank with element of or not element of. So let me put that there. We're going to choose element of or not an element to make each statement true. All right. So when we're comparing, we're going to look at one particular element. We're going to talk about it with the set. So the question is 5 an element of this set? Yes, so we would use this element. So 5 is an element of. You try the next two. -12, and then the last one. So this one was easy. We said yes, that's an element. -12, what about it? -12 is not in the other element because +12 is, but not -12. What about this last one? How do you feel about that? Anybody want to take a guess at it? Would you say it is or it isn't? So this one is not. but let's look at this note over here. 6 would be an element of this. Or if I have set 6, that is an element of 6 and an element of 7. So let's look at this distinctly. All right, this is saying, is set 6 an element of one of these? No. Okay, but is the element 6 one of these, which this is 5 plus 1 is 6, so this element would be included here because this is technically a 6 and a 7. Where you see the distinction, this is just the number 6, and this is the entire set 6. Okay, this is saying set 6 is an element of these two, which is set 6 and set 7. So careful there, and that could be a little bit tricky with the notation. Okay. All right, the next thing we're going to go over is the next lesson, so let me stop this.